Before we do problems 65 and 67, I wanted to review the concept that we talked about in the last video. When solving an exponential equation, when the bases are equal on each side of the equal sign, then that means that the exponents must also be equal. So if you look at this equation here, 7 to the x, you're raising 7 to a power, and it's equal to 7 being raised to the third power. Well, the only way that 7 raised to the third power is going to equal something that 7 is being raised to. Well, that something has to be 3, because you can't raise 7 to the third power and get a different, get the same number if you raise 7 to a different number. So if you raise 7 to a different number, you're going to get a different number than 7 to the third power. So hopefully that didn't confuse you. But I mean, if you think about it, bases are equal, exponents equal. That's the bottom line. So let's look at number 65. 65, we need to recognize here in basically every single one of the problems that we're going to do in this section, you're going to be able to equate the bases. In other words, you're going to be able to rewrite each side of the equal sign as some number to a power and the same number on each side. When we get to the next section, after we learn about logarithms, you're going to see what to do when you have a different number on each side. So you have different bases on each side. But for right now, just keep in mind that you want to be looking for that, and you want to be identifying that, okay, we're going to be able to rewrite each side as a number to some power. And so recognizing here in problem 65 that 1/5 can be written as 5 to a power, and you should know that 1/5 is the same as writing it as 5 to the negative 1. And then you should also know that 1 over 25, which is also could be written as 1 over 5 squared, is the same as 5 to the negative 2 power. So if you can quickly convert fractions to a number to a power, then this section is pretty easy for you. And then you also should remember your powers, rules of exponents, or properties of exponents, that when you raise a power to a power, you're going to be multiplying. So 5 to the negative 1 to the x power can be rewritten as 5 to the negative x. And that's equal to 5 to the negative 2. And now again we have a base. The base is the same, and we want to go ahead and I'm going to zoom in a little bit here. The bases are the same, so therefore we can just go ahead and equate the exponents. And I forgot to do my work in blue, sorry. So we say therefore negative x is equal to negative 2, and if you multiply or divide by a negative 1, you get x is equal to 2. Where's my red? There it is. All right. So that was a lot for that one. Let's go ahead and do number 67. 67, notice that we have a base of 2 over here, and we have a 4, and we know that 4 can be rewritten as 2 to the second power. And now that we have the same base on both sides, we get to equate the exponents. And I like to write therefore, because it shows, and I like when you write therefore, because it shows me that you know that why you're writing, just why you're getting rid of the exponents, or sorry, getting rid of the bases. Because I just want you to know, this does not mean that we're dividing both sides by 2. That would be a horrible algebraic mistake. So please don't do that. We're not dividing by 2 to get the exponents. We're saying, look, in order for this equation to be true, since the bases are the same, the exponents have to be equal. So that's why I write therefore. It's not a dividing step to get to this step here. So if we add 1 to both sides, we see we get 2x is equal to 3, and then dividing both sides by 2, we get x is equal to 3/2. And that is the answer.